Hello everyone, I expect you were expecting the next part of the Roberts R66 video. I put that to one side for the time being, or not for very long, because I just want to go through and test this circuit board which I've got on the bench. Now this circuit board came from China, where everything else does. And it's a 2 times 300 watt stereo amplifier, and it uses Class D topology. So in other words, unlike Class AB, which is used in most traditional amplifiers, when you get 50-55% efficiency possibly, a Class D amplifier will be anything up to 80-90% efficient. And that's the prime requirement for this in its application. And this is one of many boards I've also got here that were dropped off by my friend who I'm doing this for. There's going to be 2 of these boards in one box, plus a 6-channel 100 watt per channel board also in that box for driving these bloody enormous speakers, which are about 6 foot high, massive bass bins on them. I think they're 15-inch bass, 2 bass drivers in the bottom bin, and then 2 12 inches in the mid, and numerous tweeters on top. And so it needs a hell of a lot of power to drive all this. And this is and in one box, as I said, you'll have 3 of these boards for the left channel, and on the right channel you have another 3, so it's 2 identical boxes, one for left and one for right, with all these boards in them. So what I really want to do today is just put this thing through its paces. It's designed to run on about 38 to 40 volts in order to achieve all those hundreds of watts. But what I want to do is test it out and see if I can see what its distortion's like, see if it fulfills its promises of producing 300 watts a channel. I don't think I'll be able to test it properly because I can only go up to 32 volts on my power supply at 10 amps if I parallel the 2 power supplies together. But we'll get a good idea of what this board is, how this board is performing. So I've just got to set it all up now. So I'll come back to you when I've done that. Okay, here's my test setup. I've got 1 kilohertz coming in from there, from my signal generator, which is over there. And it's reading 310 millivolts output at the moment, not turned on, and 1 kilohertz, and the usual load on the output. I'm running it at 8 ohms at the moment, though I have a feeling this board is more inclined to produce more power at 4 ohms. But there's one big problem with measuring Class D amplifiers. They have a differential output. In other words, you can't reference it to earth. So if I connected my normal scope probe on the earth pin of that, it would really upset the Class D amplifier, because I've got an earth return through my scope probe back to my signal generator, which is on the input. As I said, you cannot connect the output of a Class D amplifier to earth. So the way around that one is you have a differential probe, which is this little black box I built a few years ago. Now that's measuring on the white cables, and what it just does is it's a differential probe. It's measuring the difference between those 2 connections, obviously, and then converting it, amplifying, converting it, whatever, to a single-ended output reference to Earth, which I can now look on the scope at the signal. And also, you see the red clips, they're connected to my HP audio analyzer, which has an option to have it as a single-ended output or a differential, single-ended input or a differential input. So I've got that set to a differential input. In other words, it's measuring the signal across those red cables and not down to Earth. So that explains the test setup. Bloody complicated. Anyway, I've discovered my differential probe I don't use very often is 100:1 ratio, unlike scope probes, which are ×1, ×10. So you can measure high voltages with the differential probe as well. But enough of that rubbish. What we're going to do now is we're going to look at the scope screen, and I can get my bracket to bloody behave itself. I think that'll have to do for now. And I'm going to turn on the signal, and we get a nice sine wave at 20 volts RMS. If I look up at the audio analyzer, it's also reading 20 volts RMS. So if I increase that signal from the signal generator, you can see it starts to square up and distort. So that is the maximum I can achieve on output with a 30.5 volt signal going in from the power supply and with an 8 ohm load. So now we're going to have a look at what that equates to on the audio analyzer. Right, so you can see 1 kilohertz, 20 volts RMS. So if I go into 19.0 special, that's now reading the watts. So that's 50 watts output. And obviously I can't test both of these channels on this amplifier. I haven't got the power capabilities to do that. But this is a good enough test for one channel, and the other channel will be identical. So that's 50 watts. But bear in mind, this amplifier would prefer nearer 40 volts up its arse, so you're not going to get full power. So another thing we can do now is we can go back to AC level and we do distortion. So we get 1.7% distortion. I think that's reasonable with class D. Right, if I turn the level down a bit more, it might get better, or it might not. Oh yeah, it's down to 1% now. And what would that equate to in 19.0 special? That's 44 watts, and it's got 1%. Yeah, that's not so bad. But you know what I think I'll do now is reconfigure for 4 ohm load and see what we get then. Okay, I've now reconfigured for a 4 ohm load by shorting that resistor out, because there's 2 in series for 8 ohms. And there's too many bloody wires on this thing. Oh, it's hideous, isn't it? Let's go to the scope anyway. Right, let's crank the voltage up. It's 100 millivolts going in at the moment. That's just about clipping and going to distortion, and that reads 19.8 into a 4 ohm load. So it's going to be more power. But if we go up to the HP signal analyzer, reset that to read AC level, and it agrees 19 point whatever. Now we can do we can set this to measure power in 4 ohms now. So if I go 19.04, I think it is. Okay, well, I kind of think that makes sense. 92 watts sounds reasonable, and bearing in mind this is not running at its full voltage, only 30 volts, because there'll be some cable loss before it gets to the amplifier board. So it's now running at 92 watts output, and just to prove that's right, it was, what was it, 20 volts, wasn't it? I'm going to do a quick calculation on my calculator. 20 volts squared divided by 4 equals 100 watts. So more or less right. Yeah, so that sounds good. Nowhere near the 300 obviously, but more, as soon as you crank the voltage up, the power will increase dramatically. Let's go back to AC level and just do one last distortion test. 1.3%. I mean, that's as good as any valve amplifier would be at that output. So I'm fairly happy with how this board is performing on the low voltage it's on. The only thing I'm not happy with is the bloody fan's not going round. I mean, it could have a temperature sensor on there that will start up. I mean, the heatsink at the moment, what's the heatsink running at? Let's get a thing in to measure it. It's bugger all, 38, 40 degrees. So there you are, 38, 39. It's bugger all at the moment. I think it's a good idea to leave it for a bit, see if the fan comes on. But anyway, I'm not going to hang around doing any more on this. So it's an interesting little project that you can get, in theory, 2 times 300 watts from such a tiny little board and a tiny little heatsink. But when it's built into a case, as it will be going in a case with its friends, the other boards, it'll have 2 fans, one at each end, blowing air across it as well. So anyway, all interesting stuff, and a bit of a diversion from the R66, which is, this is the sort of stuff I'm more inclined to be doing, because I mainly work on amplifiers and RF stuff rather than radios. But anyway, bye for now.